This is the last one of these that we need. All the Newton's third law stuff I'll do for you in the lecture. But this is the similar problem. So I've got two masses attached via a string over a pulley. So again, as two descends, one will move. Now, does one have friction? In some of the problems it will, so I'll show you the full setup with friction. If your problem doesn't have friction, you can still set it up and then just ignore that, okay? So the same rules apply. I've got to do free body diagrams, some forces each. Note here, mass 1 has X and Y forces. Note, okay? I'm going to sum forces. I am going to set those equations equal to T, and then I'm going to apply rule 1, which is T equals T. Okay, and then I am going to get to the master and move on from there. Okay, I'll remember at step 4 to expand. My weight equals mg if I haven't already done that. Then I'll apply rule 2, which is the acceleration of 1 equals negative acceleration of 2. And then figure out how to go from there. So let's set up 2 first, because it's just like 2 from before. So 2, he's not touching anything, okay? So he has weight 2, which is m2g, right? And then all he has above him is tension 2. Okay, now 1 is a little different because there's no X forces. He's not touching anything. There's nothing over here, nothing over there. He's just exactly the same he was in the previous one. Okay, in the previous one where it was just hanging straight down. Okay, 2 stays the same. 1 has forces in other directions. So I want to save enough space on my page, but be kind of small here. So we have weight 1 equals m1g. We have tension 1, yes. Now we are going to have, I'm sorry, not tension 1. Goodness gracious, I do that every time. He is sitting on the ground. Look at this right here. What is that? That's going to be normal force. The tension, this is the kicker. Sorry, I'm going to draw it in red. The tension is in the X direction. Do you see the string right here? This is where the tension is. I'll do it in red so you can follow what I'm doing. That's where tension 1 is. And you may or may not have friction here. So I'm going to put friction with a question mark. Let's set it up as if you have that and go from there. Let's do the easiest one first. Why not? Let's just sum. Okay, we did the free body diagram. Sum forces each. Let's get that done. So sum forces y equals mass times acceleration in the y. Will he accelerate? Yes. Sum forces 2y. Sum forces mass 2 acceleration 2 in the y. 2, okay, all we have is in the y, tension 2 up minus weight 2 down equals mass 2 acceleration 2 in the y. And you're really going to want to go ahead and just leave the y in all of those to remember that that's how 2 is. I put a little dot by that. I'm going to need that equation in a minute. I need to do 2 sets of equations for x. So sum forces in the y for number 1. Okay, I'm sorry, number 1, not x. Okay, so we have mass 1, acceleration 1 in the y. Is he accelerating in the y direction? Is this guy moving in the y? No. So in the y, I have normal up minus weight down equals 0. So normal 1 equals weight 1. Okay, I'm going to go ahead and box that because that's solved. Actually, I'll box it with the expansion underneath it. Normal 1